nitty-gritty details of AI, because if you really want to learn about AI, it's very very detailed, and it's very difficult to learn about AI. So we only cover the very basics, okay? But then if you don't understand any portion within it, it's actually okay, because you can always further your knowledge or from other sources also. Like we'll recommend you to go to like YouTube videos that describe what's going on in the architecture, and that's if you are very interested. Like if not, we also have code segments that allow you to actually practically do the AI instead of going in depth into what's going on behind the scenes. But we only introduce you the very basics. So we will try and explain it as much as simple as possible. And then if you have any questions along the way, don't hesitate to ask type in the MS Teams chat. So now I'll be passing the time to Xin Yin, which she will do the basics of RNN. Yeah. Oh, so I also do. Okay. Oh, you do.
Oh,
Yeah,
I,
yeah,
I okay, so we'll start off with a recap on what are neural networks. So neural networks are like human brains, but instead of brain cells, we have nodes, which are these white circles that you see in the diagrams: input layer, hidden layers, and output layer. And instead of synapses, we also have weights, which are the lines connecting the nodes. And these weights will indicate, oh, I forgot to on the camera. Okay, sorry. Okay, so these weights will indicate how strong the connection is between the two nodes, and it will be adjusted throughout the training based on the error between the predicted and actual outputs. So like they'll calculate the difference between your prediction and your target. And the goal is to minimize the error with more trainings. So the neural network will multiply the inputs with the adjusted weights, and they will be passed through the hidden layers and the network through the training. And through this, they will learn to recognize patterns, and the network will also iteratively refines its weights through backpropagation. And after the training, the model can be deployed to solve real world problems using the knowledge that they have learned. Mm. Okay, so now we'll recap on the different layers in a neural network. So in the first input layer, the each feature is represented by a node, and this layer will receive the input data. So feature can be like, let's say if this model is used to predict the price of Airbnb, then like the features can be the location, the like facilities, and like room type. And in the hidden layers, each node in the hidden layer, they will process the inputs by multiplying them with the weights, which is this line. And it will add all the calculations up and then pass through a activation function. And the final result is produced by repeating this whole process until you reach the output layer that you want. Okay, so now we'll talk about recurrent neural networks. Recurrent neural networks is like a type of neural network architecture, and is designed to effectively process sequential data where the output from the previous step is fed as input to the current step. And this is different from the traditional neural networks where all the inputs and outputs are independent of each other. And recurrent neural networks have connections that allow information to persist over time. So it's very useful for data that has to do with time or sequence. And some of the use cases of recurrent neural networks includes predicting the next word in a sentence or future stock prices. So now we look at one example of recurrent neural networks, which is natural language processing. And the network will learn to generate text character by character by capturing the context and grammar of the language. So to predict the next word of the sentence, the previous words are required, and Hence, there is a need to remember the words. And this is where RNN come into existence, which help to solve this issue. So if we take a look at a diagram, the pink circles here are like the input words from the text, and the blue circles represent the predicted next words, which is like the output. And this green bar here will kind of help to like remember the previous words. And this like arrow of the W shows that it will be passed on and like remembered throughout this whole process. And the capability of RNN also allows for applications like chatbots, language translation, and text summarization to work. Now we'll be covering an overview of recurrent neural networks architecture. Okay, so RNN handles sequential data, which is basically data that has sequence, but this time using recurrent connections. And recurrent neural networks will also remember past inputs and use this information to influence the current output. And similarly to a traditional neural network, it contains input, hidden, and output layers. And so when we talk about unrolling, we imagine the recurrent neural network as a series of interconnected layers, with each layer representing one time step. So the fundamental processing unit in a recurrent neural network is a recurrent unit. And this unit has the ability to maintain a hidden state, allowing a network to capture sequential dependencies by remembering the previous inputs while processing. So here we can see that if you look at the one of the time steps, okay, wait for the animation. Okay, so if we see this animation, it will take in input, which is the blue circle, and it will take in the hidden state, the previous hidden state, which is this pink circle, and it will produce an output and also a new hidden state. Okay, so in recurrent neural networks, we also handle inputs one step at a time, and we assign each time step to one element in the data. So you can imagine one element as like a word in a sentence. And if we look at this diagram, we are throwing the words, what time is it, as the inputs. So we will process these words in order, starting from what, then time, then is, then it. And at the top, we can see that there's also like 1, 2, 3, 4. And that's like the assigned time step to the word. And at each of the time step, the hidden state will be updated and based on the information stored in the hidden state from the previous step. So at time step 1, the hidden state will have only memorized the word what. And at time step 2, the hidden state will have memorized the word what and the word time. And using the inputs and context captured in the hidden state, recurrent neural network will then try to predict the word at the 5th time step in this scenario. So one time step represents the processing of one element or one word in a sequence. However, within each time step, we also have multiple nodes that work together to compute the information for that specific step. And the number of steps is a design choice, and it depends on the complexity of the task at hand. So like more nodes with more features will also like allow for more detailed representations of the input data and will be better at capturing complex patterns. So now we'll connect this concept to tokenization, which is important for natural language processing. So tokenization involves breaking down a sequence such as a sentence into its individual elements. And in the case of languages, one word is often treated as one element, and each of these elements becomes a time step in a sequence. In this slide, we'll be zooming into one of the time step. So in the diagrams, we can see that the hidden layers are recurrent, which means they allow information to persist and be passed on. So if you see like the top diagram, in this like small brown circle, there's like actually many hidden layers inside. And in this diagram, if you like unfold it, you can see that there's many of these small H circle. So there's actually many hidden layers inside, and the hidden layers are like passed on to the next time steps. Okay, so now we'll be covering the feedback loop, which is a system in which the output of a process is used as input for the same process in a subsequent interaction. So in other words, the output feeds back into the system, influencing and potentially amplifying the subsequent outputs. Okay, so now we'll be going through an example of a feedback loop. So we are given the sentence, I love generative AI, and we will now feed that into a recurrent neural network model. So the first step is to assign time step 1 to the word I, since that's the first word, and it will produce an output based on the input and hidden state. So the input is like I, and the hidden state for now is like nothing. And then based on this, it will try to produce an output, which is like their predicted word after I, and also a new hidden state, which is updated with the word I. And then at time step 2, it will be the word love as an input. Then the recurrent neural network will take the hidden state from the previous step, which has like memorized the word I already. Then it will update it with the word love, and the now it will produce a new output and also a updated hidden state. And they will continue this process for generative and also AI. And now it has seen all the words, it will understand the sentence context. Okay, so now we'll talk about the challenges when training a recurrent neural network. So during training, the network learns by adjusting its weights based on the error or loss between its prediction and actual targets. And this process involves computing gradients through a technique called backpropagation, which essentially guides the network on how to adjust its weights to improve performance. But here we will encounter a challenge known as the vanishing gradient problem. So as gradients propagate through many time steps in a sequence, they tend to diminish or become extremely small. And this phenomenon hampers the ability of the network to make significant weight updates and leads to slow or stop learning. So an analogy of this vanishing gradient problem would be like broken telephone if you have like played of the game. So imagine you are trying to communicate information through a long chain of people, and each person can only like pass a fraction of what they hear. So like when you reach like the last few people, the sentence will be like they don't really remember like okay, they don't really know like what is the original sentence at the start already. And so in an recurrent neural network, as information or gradient passes through many time steps, it will diminish and make it challenging for the network to effectively learn from distant dependencies in the data. Essentially, the recurrent neural network might not effectively remember and utilize the information from earlier time steps, limiting its ability to understand context in a sequences. However, researchers have also developed solutions to address the vanishing gradient problem, and architectures like long short-term memory and gated recurrent unit are designed to mitigate the vanishing gradient issue and better capture long-range dependencies. And these architectures also include specialized mechanisms to selectively retain and propagate important information through time. But we'll not be going too deep into this, so you can read up on it more if you want. Okay, so now we're having a short break for 15 minutes. Thank you. Oh, okay, guys, Samuel told me to play music, so like any um song that y'all want. It's classical music.